Good morning, everyone. Today is Tuesday, April 27th. We are going to be working in the state test prep section of our class notebook on page 6, which should say Algebra 1. Our last topic that we are reviewing for the state test / 8th grade review before we get into some new topics is our algebra skills. So our objective for today is to solve some state test level questions using those skills. Take a minute to pause the video here and try the review and preview question. All righty, guys, hopefully you paused that video, and now we're going to go ahead and look at the review question. This is a little bit of a review of some percents from our last lesson. It says in Pensacola, Florida, the average rainfall in the month of July is 7.40 inches. By October, the average rainfall decreases by 35%. And then by December, the average rainfall drops another 66 inches. So what is the average rainfall in inches in December? What we need to do here is start with our 740 for July. And then it's telling us that the rainfall is decreasing. That word decreasing is telling me to subtract by 35%. But remember, anytime we have that percent, we are multiplying it by some amount. We don't know how much 35% equals until you give it something to multiply by. So I'm actually going to take the decimal version of that percent, 0.35, and we're actually multiplying that by 740 again. We have that number twice. We're starting with the total, and then we're subtracting 35% of that total. Okay, so this is my 0.35 times 740. I made that multiplication symbol pretty big, so it's nice and clear. I'm going to figure out what this equals first before I even go on to the second step. So let me go ahead and open up my desmos.com/scientific calculator. I'm going to multiply 0.35 times 7.40, and we get 2.59. So my 740 here is staying the same. We haven't used it yet. And I'm subtracting 2.59. And when I do that in my calculator, 7.40 minus 2.59, I should get 4.81. Okay, so this is now the amount that we have for October. We did the first step. It went from July, 7.40, all the way to October, decreased to 4.81. Now, by December, it's decreasing again. It says the word drops here. So we're going to take that total and subtract, and they tell me 0.66 inches. They didn't give me another percent. So that 0.66 is already ready for us to use. All we've got to do is put that right in our calculator. And I put it right on the answer that I had before. This piece gave me the 4.81 minus another 0.66, and we should get 4.16. And we have our average rainfall in inches, should be our answer C. Oh, yep, 4.15, sorry. So I wrote this wrong. And then it matches exactly to our answer C, 4.15. There we go. If we move down to our preview question, we're going to be doing a lot of the same stuff. We're still looking for those key numbers, still looking for those key words that are telling me what to actually do. But we are not only using percentages now. We're going to kind of mix in our variables. We'll have some X's in there and use those algebra skills and calculator skills to solve some of these. So my preview says, at a store, a hat has a regular price of X dollars. But during the sale, the price of the hat is discounted by 20%. The expression 0.8x describes the discounted price in dollars of the hat, but which expression would also describe the discounted price? So what they did here is they started you with an X amount. So just like we started with the 7.4 up here, I'm going to start with that X down here. Then they say the word discounted. So we know we are subtracting some type of amount. And when we have a percent, we're not only taking that percent, and I'm using the decimal version of it here, we're multiplying by that total again. Remember, anytime we have a percent, it has to go along with that total so you can actually figure out how much that is, okay? If the hat was originally $100, then 20% of that would be $20. But if the hat was originally $1,000, then 20% of that could be $200. Okay, we don't know how much that discount actually was until we multiply it by that original price. And what they were telling us is that this expression should be equal to the one that we just wrote, 0.8x. And here's the reason why it is. Okay, so we just wrote one. We actually found the answer already. It should be D. That matches exactly to what we wrote down. But here's the reason why it's equivalent, why it's equal. This X is telling me 1x minus 0.2x. When I do that in my calculator, 1 minus 0.2, it can turn into that 0.8. So they were just using their like terms, combining them with that subtraction, and it turned into that 0.8 that they gave us. And we're going to learn some other tricks for finding those equivalent expressions, even if you get a little bit mixed up with writing your own equations. So even if you couldn't write that green equation here and find it in the first place, we're going to take a look at some tricks in the calculator to help us solve that without it. Before we look at those calculator tricks, we have to remember one really important piece of information. Okay, we can only use the X button in the calculator if we or you already know the value of X, or if you're choosing a value of X to try. For example, we can use the calculator buttons shown below to answer this type of question. If they tell me to evaluate the expression negative 5x plus 8 when x equals 3, then what we need to do is tell the calculator that x is equaling 3. Click a 3, we can click store, x, and then enter. after this, oops, the calculator will think that x equals 3. If you do not do this part, the calculator might think x is 5. It might think x is 100. Okay, the calculator doesn't know what x is unless you tell it what x is. After you tell it, then you can use our X button and type this exactly as it is written. Okay, negative matches to the negative button, 5 matches to the 5 button, X button, plus button, 8 button, click enter, figure out what it equals, and the calculator should tell you that it is -7. Okay, if you do not tell it what that x equals 3, then it will not tell you the correct value. The calculator does not know what x is unless you do first. Okay, or we could use that same sort of thinking, that same skill, if you are guessing what x is, if you're taking a guess, or if you're choosing a value just to try out. Okay, so in this example, they gave you a value. You already knew exactly what x should be. But I want to show you a trick for equivalent expressions where you could guess what the value of x or n or whatever variable is to help you find the correct answer. Okay? So there's going to be 2 methods that I use to solving this, and I'm going to split my page down the middle so that I can show you those 2 methods. The first one is just to take our expression, -18 minus 64n. And when they are giving me these types of choices, I'm kind of seeing that they took some number out. You can either take a -2 out, or you can take a +2 out. Okay, they are taking that onto the outside and leaving the rest in parentheses. So that's kind of giving me a hint to use my factoring skills. If you remember factoring from when we did it during the algebra unit, it is our area model method backwards, or our box method backwards. So that's what I'm going to try here. Let's put this up. My 18 goes here. -64n goes here. And then the choices are telling you you can either use a 2 or a -2. And I think I'm going to go ahead and try the -2 first, because both of these are negatives. So that should work out pretty well. Let's see what happens. -2 needs a +9 to make 18. Okay, remember we're working backwards. So once we start using that -2, we're finding the value that we need to multiply to get that inside number. I always have a plus on top in between. And now -2 needs some number to make 64. And that's going to be a 32. Okay, 2 times 32 is 64. And I need to have an n here. We're using our factoring skills, my area model method backwards. And we should see that C is the correct choice. -2 comes out, and the 9 plus 32n stays on top, which means it is inside the parentheses. Okay. Here's how I could have solved this without my factoring skills. Okay, it's a really cool calculator trick. If you like it better than using these algebra skills. It's totally possible to do on the state test, possible to do during 8th grade, and it might make things faster as long as you do it correctly. So here's my cool trick. I'm going to pretend that n equals, let's say 5. Let's do a nice, easy number. It's not a negative. It's not a 0, so nothing weird will happen. I'm going to guess that n equals 5. And I'm going to put that in to my original equation. Okay, negative 18 minus 64. Instead of that n, I'm going to say times 5. And I'm going to solve this right now. I need 64 times 5, so let me do that. 320. Remember, we're always following PEMDAS, so that's why I multiplied first. Now I need to subtract that negative 18. Negative 18 minus 320 equals negative 338. Okay, so we took a guess. We chose to use 5 for that n. And we got the value 338, which is negative. Now I can use 5 in these n spaces and figure out which one is going to be equal. Okay, I'm going to copy all of these choices in my calculator and figure out which one will be equal to that original equation. Here we go. Choice A says negative 2, parentheses, 9 minus 32. And then it says n, but remember we're changing that to a value. Put my parentheses. Nope, choice A is not equal. Let's try choice B, positive 2 on the outside. So I'm going to go ahead, I'm just going to copy this, Control C. Uh-oh. And I'm trying choice B, but I'm taking away that negative because choice B is positive. Uh-oh, still does not equal negative 338. What about choice C? We already know choice C is correct. Let's see if it works out with this method. Copying what I wrote again, this time choice C has a plus sign right here. And we see it matches the exact value. When I use n for that variable, the value matches. And we could do the same thing for choice D, and it would show us again that D is not correct. Okay. Those are my two methods. I can solve it using my traditional algebra skills. They gave us a hint that we would be factoring because they're showing these answer choices using our parentheses here, which reminds us of distributive property. And we can do that backwards to solve. Or we can use our calculator trick, and we could even have stored 5 as x, okay? Stored 5 as x, and use that 5 with the x button to try each of these. Okay, we can only store x and use that in the calculator if we know or are taking a guess about what x is. Testing out a value. I could have done the same thing with n equals 2, n equals 5, which we already did, n equals negative 10. You can test out any value and figure out which one is equal anytime that they are saying the word equivalent. Anytime that they are saying the word equivalent. Okay, the word equivalent means equal. So either you know how to use your algebra skills to write an equivalent expression, just like we did the first time, choice C, or you know how to use your calculator during this really cool trick and test each one until you find the equal value. All right, let's try that one more time with exercise 2 before I let you guys start your practice. It says the regular price of an item at a store is $P. The item is on sale for 20% off the regular price. Some of the expressions shown below represent the sale price in dollars, but some of them do not. So they're asking us which ones actually would be equal, which one would work. Okay, so here's what we want to do first. We need to take a look at our situation, find what they're starting with P, just like we did in the DIN. Find some of those keywords. For example, off tells me they're subtracting. Use our percent. I'm going to switch that over to the decimal version of our percent, just like we practiced doing during the last lesson. Anytime we have a percent, we have to give it some type of total to multiply by. And now we can automatically see that choice D should be correct. That's what we wrote just from the situation. And if we look at these choices, choice A does not have a D in it, and choice B does not have a D in it. So it can't be either of those. Choice C has one, and choice D has one. But they also have B and C, so we have to test expression B and expression C. Let's test it out. If we use our calculator trick, we can take a guess, or we can choose a value for P. I'm going to choose maybe 10. 10's a pretty nice number. Let me choose 10. And if I put 10 into the equation I already have, let's see what that's going to equal. We had a P, which we're saying is 10, minus our 20% as a decimal, times P again, which we're saying is 10, and that should give us the value 8. So using this kind of fake amount, we don't know if the item is actually that amount, but we're using that fake number. Our expression should equal 8. Now let's figure out which one of these equals 8 also. I'm trying to find which one is equal. I'm going to go ahead and let's start with choice C. Let's see what happens with that one. 1 minus 0.2 P. 1 minus 0.2, and we're using P as the value 10. Uh-oh, that does not equal 8. It equals a -1. So it cannot be expression C, which means we're crossing off this choice. And we just have to make sure expression B would be correct, 0.8 P. Let's test it. We said P is 10, so I'm using that 10. Yes, it is equal to my original equation. So yes, expression expression B should be the other value that we choose, the other equivalent expression. And there we go. If you had noticed, this is actually the exact same as the preview that we did at the beginning of class today. Okay, we started with some value. We had a 20% off sale and had to find an equivalent equation, right? X minus 0.2x. They actually gave us that 0.8, and we had to find the matching one. We did this using our algebra skills. But now that we know that cool calculator trick, you can choose any value to test each expression and figure out which ones are equal. Expression D and expression B. There we go. Go ahead and try and do the same things for the practice section. We've got another equivalent equation. You could use either method. We've got a kind of fill in the blank here, which again is an equivalent equation because they're asking you this side will match to this side if I put one of these in. So which one will it match to? We've got a triangle question about the perimeter, which we have actually solved before in our algebra unit. So you're using that information to write your expression and making sure that you have that definition of perimeter. Last expression, we have the word product. So they're telling you that 3 is being multiplied by this amount. Again, they want an equivalent expression, which represents the same thing. You can use both methods. 44. Now they're asking you which one is not equivalent, so be very careful with your reading. They are saying that 3 of these are going to be equal, and you need to choose the one that is not. One last question for the exit ticket. Same equivalent expressions, same 2 methods. If you know how to simplify this and find it already using your algebra skills, that's awesome. If you wanted to practice using that calculator trick, that's great too. Complete your self-reflection, and then you're choosing at least one quiz from the EE Standard Quiz 1 list on Canvas. That's it for today, guys.